15 asks, which of the following is the best leaving group? If we have a nucleophile attacking some starting material and we're going to displace a leaving group, which one of these is going to be the best at leaving? Let's just look at something like this. And let's say we have each of these leaving groups. We have a methyl group right there. We have a hydroxyl group right there. We have a bromo group right there. Or we have an amino group right there. If a nucleophile is going to attack, and we're going to have that attack and displace a leaving group, we need to talk about leaving group ability. What would happen to each of these if they left? If this was to leave, we would end up with NH2- floating around on its own. Over here, we would end up with CH3-. If this were to leave, we would end up with a hydroxide ion. If this were to leave, we would end up with a bromide ion. So leaving group ability is determined by the stability of that group once it has left. The more stable it is once it leaves, the better leaving group it was, because it won't have as much of a problem leaving. NH2- is very unstable. That's no good. That's an insanely strong base. So that's not going to be a good leaving group at all. CH3- is even worse. That's a crazy strong base. Hydroxide is possible in basic solution, but not a very good leaving group. This is not going to be commonly seen as a leaving group unless we are in strongly basic conditions. But bromide is perfectly fine. In fact, we know that HBr is a very, very strong acid because of how stable the bromide ion is on its own. So if something is very stable, it's going to be a very good leaving group because it has no problem leaving and being on its own. So this one will be C, the bromine.